Hello class 10. In the previous video presentation, we studied about cubes and cuboids, volume formula, lateral surface area formula, and also the total surface area and how they are being derived. And before that, you were shown the formula for frustum of a cone using a real life problem of a big company like the Coca-Cola. Now that you know a frustum, a geometrical shape we so often use in our daily life, like the glass to drink water, is also a frustum, which is actually a part of a cone. So in this video we shall study about the volume of a cone and how early mathematicians, without the modern sophisticated scientific instruments, were able to find the volume of a cone using the formula for volume of a cylinder. Also, there is a borrowed demonstration to get the volume of a cylinder and then a cone and eventually the volume of a sphere. So recall the previous video about cube and cuboids. You saw that a rectangle when extended forms the rectangular prism, usually called the cuboid. A triangle on extending forms the triangular prism, and a circle on extension forms the cylinder. We shall visualize the volume formula of a cylinder with the help of this cuboid, where the volume is equal to the area of the base multiplied to the length. The same way we get the volume of the triangular prism equal to the area of the base triangle multiplied to its length. In case of cylinder too, we use the same principle as cuboid and prism. This circular base area equal to pi r square sits here, and the length extended, which we call the height, shall shift here and give the formula for the volume of a cylinder with base radius and height as pi r square h. Now it is a 3D quantity and its unit shall be cubic units. Remember this formula and we shall use it in this video again. Before that, let's calculate the volume of a cylinder with radius 2 meter. So we replace it in our square, we get 4 meter square. We next put the value of pi, which is equal to 3.14. On multiplication we have it to be 12.56 meter square as the area of the base. Now to find the volume we need to multiply this area with the extended length. Now let this length be 10 meters, so on substituting and then multiplying we get to 125.6 cubic meter as the volume for the cylinder. Now we shall see the formation of 3D objects like cone and sphere, which are not formed by extending a 2D object but by rotating it about an axis. Just like this, if we rotate a right triangle about the perpendicular, we get a right circular cone. To get a sphere, rotate a circle about any of its diameter and have a sphere. Now let's find their volume. Okay, here you can see that the height of the sphere, cone and cylinder are same. Let us keep the sphere aside for now. You see here that the base circle of the cylinder and that of the cone, the base circle, they are taken as congruent. That is, their respective radius are equal to the other. Now we shall try to fill the cylinder with as many cones as we can, filling up to the brim and then pouring it into the cylinder. We have to mark it 1 just to check how many cones we fill or we require to fill the cylinder completely. We repeat the process. We fill the cone up to the brim and then pour it back into the cylinder. Till now we have 2 cones giving this much portion of the cylinder. Now the third one, and you will see that 3 cones completely filled the cylinder, right? Hence we can conclude from this experiment that the volume of 3 cone is equal to volume of 1 cylinder, provided their radii r and the heights h are equal. Now recall the volume of a cylinder, which is pi r square h, hence volume of 3 cone is pi r square h. So just taking this tree of the from left to the right, we have volume of cone is equal to 1 by 3 pi r square h, and we are going to use it using almost similar technique and a little algebra basics. We shall discover the volume of a sphere. This time a water-filled cone of the same height as the sphere is taken to fill the sphere with the help of the square pyramid to prevent water from falling outside. Here we have one cone and two cones of the same height and radius as the sphere completely fills the sphere. So recall the volume of a cone. We have volume of two cones equal to one sphere. The height of the cones is same as the height of the sphere, right? So similarly, the radius of the cone is also same as the radius of the sphere. Now let's put on the volume formula of the cone, which we have pi r square h by 3 for both the cones, right? Because the radius and heights are same, and we sum up, and which is equal to the volume of a sphere. Now check on the radius of the cone and the height of the sphere. Since the radius is same as sphere, they fit here, and also we can fit it vertically like this, but you can see that it's actually the height which is same for the cones. So these heights h of the cone in the formula can be replaced with r plus r, which is together twice r. Now 2 being the constant can be shifted left by convention, and also r square into r gives r cube. Thus we have 2 pi r cube by 3 plus 2 pi r cube by 3, which is the volume of the sphere. 2 pi r cube by 3 is also the formula of a hemisphere. A hemisphere is a half sphere, so do remember it too. Okay. Now here we can also write it as this way. Take pi r cube common and add the coefficients. Since the denominator is same, hence the fractions can be combined using only one denominator and adding the numerators 2 and 2, as you can see here, and finally giving us the formula for volume of a sphere as 4 pi r cube by 3. Example time. Take a sphere of 2 meter. We have the volume formula, which is equal to 4 by 3 pi r cube. R cube means r into r into r. Putting the values for each r, we have on multiplication equal to 8 centimeter cube r cube for r cube, right? Now putting pi as 3.14, we have on multiplication 25.12. We still need to multiply 4 by 3. So volume of the sphere is 4 into 25.13 centimeter cube by 3, that is 33.49 cube. Lastly, we have the cone with radius 3 feet and height 9 feet. So we just put the value of radius in r square. We have 3 feet into 3 feet, which is equal to 9 feet square, and then we put the value of pi equal to 3.14 on the multiplication. We get 28.26 square feet. Now that is the area of the base. So we need to multiply it with 1/3 of the height. Height is 9 feet. We replace it and we get that to be 3 feet ultimately. And on multiplication we get 84.78 cubic feet as the volume of the cone. So in the next video we are going to study about the surface area of cylinder, cone, and the sphere. We shall also study about the volume and surface area of the hemisphere in that video.